Now that we're coming to the end of our machine learning module, we'd like to remind you what the 4 course learning outcomes are for this class. These are the objectives that you'll be evaluating our class on, and they are fourfold. First, understanding the basic concepts of machine learning. This means the specific diagram that we showed you in the beginning, with the learner as the central tenant, but being exposed to both training data and testing data. Each machine learning algorithm has a certain hypothesis space, which indicates the type of bias that it is aligned to, looking at the cast of future data instances in. Remember, if a learning algorithm doesn't have a specific bias, it becomes futile to predict future observations because it can only resort to memorizing what it's seen in the past, and it cannot generalize. We also talked about bias and variance trade-off, which is related to overfitting and underfitting. Here we want to understand the concepts of regularization and validation as ways to make sure that whatever we see, the performance in the training data holds for our testing data. We also want to be able to apply an appropriate machine learning algorithm for a given problem. Each of the algorithms that we went over has specific properties about what it can model and what it finds difficult to deal with. For example, some of the algorithms look at a linear combination, others look at conditional combinations. Still others have problems with training data that has attributes that are correlated or uncorrelated. We also talked quite a bit about evaluating the performance of a machine learning solution. This means, for example, thinking about the evaluation metrics in terms of precision and recall, in terms of classification, and for unsupervised as well as reinforcement learning, thinking about other systems, such as the complexity of the solution, as well as the reward function or fitness function that we would see in RL. Finally, very importantly, we want this module to connect with you practically. This is why you've had to do a machine learning project. We want you to be able to take machine learning as a toolkit to carry out machine learning experiments in the future and not stop just at the one-stop single macroscopic measure of performance. We need you to understand how the design decisions in hyperparameters relate to how the data is being viewed by the machine learner and whether there's better optimal solutions rather than carrying everything out through grid search. Now, those were the primary objectives which you will be offering our feedback on when you give student feedback to this module. There are some really important secondary metrics that we've tried to engineer in this course. In particular, you've learned much more about Python and how it relates to machine learning. It is one of the most easy and straightforward programming languages to use. You can see its ubiquity is very common within machine learning. We've also emphasized the use of Jupyter Notebook through our Colab use. We think this is a really intuitive way to mix visualization with code. And both in industry and research, you'll find more and more people using notebooks as a way of sharing information. They definitely have some limitations, but they're a good place to start if you want to just try some experiments. Reaching farther than Google Colab is then to use all of what you've learned in a practical project. So many of you reached out to use Amazon web services as well as other functions in the command line to carry out your machine learning on your own. We think you learn best by applying what you know on a project of your own design, and importantly, through things like steps, your poster, and video, communicating it with others. You'll find that there's a lot of mystery in the public's eyes about what machine learning can do. And you who have studied it, it's part of your mission to debunk that problem. Now, there are lots of things we didn't cover in machine learning because this is a course, an introductory course only with 13 weeks. There are many things, but probably the most glaring omission is more about Bayesian models. We did touch upon this in a little bit in tutorial when we went over linear models and how noise can be recovered as a way of thinking about the regularization. You'll likely see it again in other machine learning modules that you'll take at the postgraduate level, or when you go on exchange, or in other NUS machine learning modules, both here in the School of Computing, as well as in the Faculty of Science and Engineering. With that in mind, let's turn back to our mascot. So we'll find that there are many other modules that you can relate to that underpin machine learning, such as statistics and artificial intelligence. But there are many other modules that you can take within the School of Computing that are going to build up on your knowledge that you've learned in our machine learning course. Then there are other places where you can apply machine learning. There are many areas that you can see that are only growing in importance where AI and machine learning are having more practical relevance. We encourage you to explore all of these opportunities and to remember that the data in a particular domain is always special, and someone who understands the data can also fit that with their understanding of machine learning to enable better, more optimal, more transparent, and justification in their machine learning solutions. Now, everyone needs to know about machine learning, but perhaps only a few really understand it. That's you, our learners who have gone through this course. You have the ability now to take machine learning forward and do something useful, practical, and impactful with it. We wish you the best as you go forward. We'd like to acknowledge all of the various TAs that have served in this course, including our graduate TAs who have basically helmed the 3 pillars of our work, which have been the Google Colab Notebook and Assessments in Coursemology, the tutorials, as well as the projects. We also want to thank all of the TAs who have been involved in actually giving the tutorial sessions. Make sure you're ready for the final assessment, which will come on Monday, the 25th of November between 1 and 3 o'clock. The tentative venue, which I'll need to write here, the tentative venue is MPSH 2. There'll be no electronic devices that you'll be allowed to take in, but it is an open book exam, so any physical notes, including Python notebooks that you've printed out, or these slides, are going to be fine for this course examination. Once you've finished your CS3244 machine learning course, we'd invite you to stay in touch with us through Facebook. You can just search for CS3244 as a string in Facebook, and you'll be led to our alumni page, where we share more on ongoing things that are happening in machine learning, as well as job announcements made by our alumni, perhaps you in the future. Well, thanks for joining us on our journey, and we look forward to seeing you again around SOC. Bye now.